Last section, 2.5 multiple angle and products to sums formulas. So again, all these formulas are on your unit circle handout. One thing, just so that you know which one is which. Multiple angles means when you take a trig function and there's a number and a variable or any multiplication in between two numbers. Half angles is when you're dividing. Square of trig functions, we've been dealing with this whole unit, and then products of two different trig functions if it's the same angle. So, and again, the double angle formulas are on your trig functions, your unit circles. So that's where we have different formulas to solve. So let's look at this first one. 2 cosine x plus sine 2x. It's right here. This is a double angle. So I can rewrite this. So I'm not going to rewrite this 2 cosine. I'm going to leave that 2 cosine x exactly how it is. But I'm going to use my double angle formula. And when I have a trig function of 2 sine, or sine 2u would be equal to 2 sine u cosine u. So in this case, we have a 2 sine x cosine x is equal to 0. Just like that. Not good handwriting, but just like that. And then this is what we've been working on this whole chapter is what can I take out of both of these? I can take out a 2 and a cosine x, leave me with 1 plus sine x right here. And this is equal to 0. And now I can set both of these equal to 0. So I have a 2 cosine x equal to 0 and a 1 plus sine x is equal to 0. So in this case, I'm looking at cosine x is equal to 0, and here I'm looking at sine x is equal to negative 1. So this first, remember, cosine is like when x is 0, so that'd be like right here and right here. So those 2 points are pi over 2 and 3 pi over 2, but remember, because, whoops. So for this first angle, remember, unless if it says it's in between 0 and 2 pi, or have some other parameters like this next one will. This is our pi over 2, because that's my angle right here, will be equal or plus 2 pi n. And this angle right here is my 3 pi over 2 plus 2 pi n. And that was for our cosine. For sine negative 1, remember, negative 1, or sine is going to be our y value. So this right here is our y value at negative 1. So we actually already have that answer. So these two are our final answers. So the second one, use the following to find sine, cosine, and tangent, because we have an equation for each one of those. So first and foremost, it gives us this parameter. So really what it's telling us is it's going to be in between 3 pi and 2 pi, which is the same thing as my first and second quadrant. That's what I'm looking at, my first and second quadrant. If I draw this up in my first and second quadrant, if cosine is positive, it has to be in my first quadrant right here. Cosine is my adjacent over my hypotenuse. This is where you do a squared plus b squared equals c squared. And you would get this third side would be 12. Okay, so now I'm going to do a different color for each. So if I'm going to looking at sine of 2 theta. So this is like my theta right here, sine of 2 theta. Sine of 2 theta is going to be equal to our 2 sine of our theta. So 2 sine theta. So I'm going to use this right here. 2 sine theta would be at my opposite over my hypotenuse. Sorry. And I'm going to actually just rewrite the equation first because 2 sine u times cosine u. So this is my equation. So now I'm going to replace the numbers with 2 sine is 12 over 13. And my cosine u is going to be my adjacent over my hypotenuse. And if I put that whole thing into my calculator, I get 120 over 169. So that would be my sine of 2 theta. So now if I look at my cosine of 2 theta, so looking at just the equation first, the equation is 1 minus 2 sine squared u. 1 minus 2 minus sine squared u. That's what I'm going to say. So we're going to have this 1 minus 2. We're going to find sine of u. So sine of u is my opposite over my hypotenuse, so 12 over 13. And that's my equation I use. So if I put that into my calculator, I get it's equal to negative 119 over 169. And last but not least, we're looking at our tangent. So our tan of 2 theta is going to be equal to 2 tan u over 1 minus tan squared u. So when we're looking at this, it would be 2 tan u is my opposite over my adjacent, whole thing divided by 1 minus my opposite over my adjacent squared. Now, one thing that might be beneficial to you is making sure to use their fraction key for this one. And you should have got it as negative 120 over 119. You notice that I left them all in fractions. That's how I prefer you to have your answer as in fractions. So question 3, it says rewrite sine 3x in terms of sine of x. So this is where we're going to have to actually rewrite sine of x as a sum, and then we're going to have to use last unit's equation. So I can rewrite this as sine of 2x plus sine of x. And now I'm going to use our sum equation. Again, that was from 2.4 when we have our sum equation just like this. Now I'm looking at this equation, and I have 2 double angle equations right here and right here. So I'm going to be replacing this double angle and this double angle right now with our 2 formulas. So this is what I have right now. So I'm going to kind of even this out. I'm going to multiply here and here, and I'm going to multiply my cosines together. Now it looks like I'm dealing with a lot of sines and not a lot of cosines. So we have that identity. So this is why we work on identities. We know that cosine squared is equal to 1 minus sine squared x. So now I can distribute that here. And now I can simplify. So I have 2 cubics, I have 2 sines. So I have right here is my final answer. We have 3 sine x, because 1 right here, 2 right here, minus a total of 4 sine cubic x. That's my final answer because I'm asking you in the question to write it in terms of sine of x. So no 3 or 2 in the equation. Next, we're going to get into our power reducing formula. So right here. So again, just to reiterate, so far we used our double angle formulas, and we've used our sum and difference from last semester or last section. And now power reducing formulas. So first, looking at this, rewrite this in terms of first powers of cosines of multiple angles. Well, if you look at this, we start with sine of squared. We get to cosine with multiple angles because of that too, that's multiple angles. So really, we're trying to use this formula right here to write this in cosine. So first thing I can do is rewrite sine the fourth as sine squared squared, because that formula is with sine squared. So right here, I can simplify that sine squared into, I'm going to write it down below because I'm going to need this space, to 1 minus cosine 2, I forgot the x up here, x squared x, 2x over 2, this whole thing squared. Now I actually have to multiply this out. So when you multiply this out, remember when something's squared, it's multiplying by itself. We're going to have 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. So we're multiplying fractions, so we multiply the top, and we multiply the bottom. So when I multiply the top, I'm going to be foiling. So I have my first outside, so I have my outside, that becomes a negative cosine 2x, or my 1 times negative cosine 2x, so negative cosine 2x. My inside is also negative cosine 2x. My last becomes a positive cosine 2x squared. I'm going to put a little square there, all over 4. So one thing I notice, I don't really want to deal with this 4 on bottom. So I'm going to rewrite this. So I have a 1/4 out front. So that's this 4. That's the 1/4. The whole thing has the 1/4. And I'm going to rewrite the top as 1 minus 2 cosine 2x plus cosine squared 2x. So again, the question is multiple angles, not by squares. So we also have this cosine squared. So we can replace that last cosine squared with this double angle theorem. So we can have this. We're replacing that cosine squared. Now, one thing you're like, where did that 4 come from? Well, if you look at the formula, it's cosine 2 of the angle. My angle here is already 2x. So this is saying 2 times 2x. So that's where that 4x came from. So now I don't like how this is written. I'm actually going to distribute that 1/4 back in, and then I'm going to see where I can simplify. I'm also going to break that up. So I'm going to have this 1/4 right here minus 2, actually, so bringing the 1/4 to each of these. So this was 1/2. This is 1/2. So that's where that 1/8 comes from. Now I can combine these two like terms. I cannot combine these because this is 2x and this is 4x. And finally, because of my denominator here, I can take out a 1/8. So 1/8 on the outside, leaving me with 3 minus, because I took out a 1/8, that would be the same thing as a 4 on top, 4 cosine 2x plus cosine 4x. That right there is my final answer. So a lot of these questions in 2.5 is just finding the formula and simplifying with it algebraically, which that's where obviously how long this can be confusing. We're making this into 2 parts. So that is part 1.